So let me first open up the course page. Does anyone have any questions? Who all tried to install Arduino on their computer and get it to program their board? And did anyone have any luck with that, or getting it? I know we were talking about this issue you were having with.
I have to recognize it now, so.
Oh, you did? Nice.
I don't know.
Well, just needed to.
Just a little behind, I guess.
Just needed to talk to me, and that fixed it. Yeah. That's good though. So yeah, I sent out the last lecture, which has the recording of how to get it set up and everything. If you have any more questions, just let me know. I'd like for y'all to get that working this week and be able to upload the examples to your board, like the blinking LED and stuff. So I was looking at how long we have left in this class today. So I think we've got, like, not counting today, we've got 3 lectures before Thanksgiving and then 3 after Thanksgiving break. And then we have the final exam. Have you all been studying the final exam material that I sent out? Good. Okay, you feel like pretty comfortable with it? Okay, it's a lot of tricky stuff on the finals, so I'm just kidding. There's the final exam is just going to be where we present the labs that we worked on at the end, so don't worry. Yeah, I was just joking. That was kind of a mean joke. Yeah. So I think we're going to get to everything. I'm going to do steppers, and we might not get to brushless DC motors. We'll have to see how that goes. But I want to make sure I give you all time to work on the final project. And I'm going to send out an email about it, but I would like y'all to try to come up with some ideas for projects you'd like to do for your final project. So keep in mind it's something involving our microcontroller board and possibly the motors and the driver board. It can be really whatever you want, but I'd like for you to let me look at it and see if it's feasible, because like if you need to buy parts, we'll have to see if they're available and how expensive the parts are, and just if it sounds like it'll make a good project, if it's the right difficulty level. So I'm going to send that out as an assignment this week, but try to be thinking about that, what you'd like to do, and hopefully you can incorporate a lot of the elements of the class we've learned in. Like if you want to do something with a DC motor, and you can use your DC motor hat to do that. That would be really great. Does anyone have any questions about the schedule for the rest of the class? Yeah, go ahead.
How many weeks do we have for like the final project? Like 2, 3, 4?
Yeah, that's a good question. So on the syllabus, pretty much everything after Thanksgiving break, all 3 weeks, is devoted to the lab. And if we can figure out now kind of like what you're going to work on, like if this week, if y'all can send me some ideas, we can figure that out, then you could get a head start if you wanted to, or you could be thinking about it and figuring out what you'll need to do for the project. So I want to get that started as soon as possible so you all have more time to do it. And yeah, so you'll definitely have the time after Thanksgiving though to work on it. But if you figure it out before Thanksgiving, then you can work on it during Thanksgiving, which sounds really fun. A lot more fun than eating. All right, so raise your hand if you were able to program your board with this Arduino thing yet. If y'all got it, nice. Okay, don't despair if you have not yet. You still have time. But I was thinking that today it'd be good to go over a little bit more of some of the topics and how to program using Arduino. So one really nice thing about it is there's a lot more documentation about Arduino than there was CircuitPython, because it's been around longer and there's a lot of boards that use it. And also it's nice, it has examples built in. So if you go to, there's basic examples. If I open up there's one called bare minimum. This is all of the program. Can anyone tell me what these two parts of code mean, the setup and loop?
The setup runs once, and the loop runs over and over and over again.
Yeah, exactly. So what kind of things would go in setup and what kind of things would go in the loop part of your code? Just as an example, if you can think of something.
I think would include stuff like defining any special functions you want to use for your code, and importing boards or information packets.
Yeah, that I would modify that a little bit and say, if you want to make actual functions, like you know how we made a function that was like mapping one value to another, you could probably actually just put that up before setup. But yeah, you're right. Like if you, let me open up an example that uses it. So here is the blink LED example. And so here's their setup function, and then here's their loop function. So the only thing that's happening in the setup is they're setting up this LED pin to be a digital output. And why does that go in the setup and not down here in the loop part? Like, why don't you just put it right here?
Once it's set, it stays set.
Yeah, you only have to set it once, and if you don't change it, it's going to stay a digital output. Like if you put it down here in the loop, it's going to say, okay, turn this pin into a digital output, make it go high, wait a second, make it go low, wait a second, and then it jumps back up to the beginning and says, make this pin a digital output. You don't need to do that over and over. You just have to do it once. It probably would work fine. It just is kind of unnecessary. Unless you're changing it to something else and then you have to change it back. There's no reason to do that. Can someone explain what... So this function, it takes the pin and output. If I put input here, what would that do differently? If I made that... if I said pin mode input, what would happen? That's not exactly right. That's kind of the right idea. So if it's a little bit more like at a more simple level what's going on here. As this program is written, it's not going to send anything back to me. So I just uploaded it to my board, and if I open up the serial monitor, there's nothing being sent out. Even if I make it an input, it won't send anything out. But what this does is this pin, which, do y'all know which pin this is referring to when it says LED built in? Yeah, so like every board, almost every board has an LED built in. And so like when you tell it what board you have, it knows, well, the built-in LED for ours is on pin 13. And it's like I could just put in, instead of built-in LED, I could just do 13 like that. But then I'd have to go down here and also do 13 here and here. So it'd be like make pin 13 input, then set it high, and then set it low. But what it means to make it an output is that you want that pin to drive something, like it could be a LED or an output. If you make it an input, it's you want to read a voltage with that pin. So you all remember when we did the analog input, and it was like you could read the value of your sensor, or you could like touch it with your finger and see the voltage change. It's kind of the same idea, except a digital input, instead of being a whole range of values, like between some minimum and maximum value, it's either just a 0 or a 1. So there's some threshold, like so the highest voltage you can read is 3.3 and the lowest is 0. Somewhere in the middle, probably like around halfway, so like around 1.6 volts is the threshold. And if you put a voltage lower than that in, it's going to register as a 0 for a digital input. And if it's higher than that, it's going to be a 1. So a digital input is an input that can either be a 1 or a 0. And for a lot of things, that's all you need. Like if you have a button, you're going to know if the button's pushed. You don't care what the actual like voltage of the button is. You just want to know, is it high or is it low? And if you do an output, you tell it what value to take on. Like you tell it, I want it to go high or to go low. If it's an input, you don't tell it to go high because it's going to go to whatever it's connected to, whatever button or anything. So it's kind of like, it's always safer to make it an input at first, because if you make it an output, and say that I have pin 13 as an output and it's connected to ground, and then I try to write it to high, it's going to try to make that pin go up to 3.3 volts, but it's connected to ground. So it's going to make a lot of current flow through it, which might, since it's like a short circuit, it might damage the board or damage that pin. So it's always safer to have the pins be an input, because when it's an input, no current really flows in or out of the pin. It just kind of reads whatever voltage is connected. And it's a little bit like if you have a voltmeter, and you know how with voltmeters you can either read voltage or you can move the leads to read current. But if you try to, like, if you leave it set to read current, and you try to read a voltage, it'll cause a short circuit and blow the fuse in your meter. It's kind of a similar-ish idea where it's like, it's always safer to leave it on the voltmeter on voltage mode until you need it for current. It's kind of the same thing. It's always safer to leave this as an input than an output. So I think, let me put it back to output. Whoops. And then to upload it, you have to make sure you pick the right board, the Feather M0, and the right serial port, which mine's already selected. And then you just click upload. And so it says it uploaded, and you can see the LED is, this one right here is blinking on and off now. So what will happen if I make it, if I change this back to input, which is, like I said, not the correct way to do it. Do y'all see what's happening? You might have, it's actually going to be hard to see. It's not really blinking, but it's actually turning on very dimly. So this is kind of a weird thing. If you have the pin as an input, like that means you don't want to drive anything. Like you're not trying to drive an LED. You just want to sense what's connected to. But if I then write the pin high or low, what it does is it connects. You know how like when a pin's not connected to anything, it kind of floats around, like it can float up high and low. Well, if I don't want it to be floating, there are these internal resistors called like pull up or pull down resistors. So if I digital write it high, it'll attach a pull up resistor to that pin, which makes it float up towards 3.3 volts. And that way, like if I have a button connected, the button could make it short to ground. And then when I release the button, that pull up resistor would make it kind of go back up to 3.3 volts. So they don't damage anything because it's not like it's actually driving it all the way to 3.3. It's going through this really big resistance, so only like a few microamps or milliamps can get through. But it's actually enough to make the LED light up very slightly because it's going through, you probably can't see it, but it's actually very dimly turning on and off. So that's just kind of an interesting side note. You probably don't need to use that, but I was kind of thinking this wouldn't do anything when I made an input. And then I saw that it was blinking, and I was like, oh yeah, it makes a little bit of current go through it. So let me open up another example. So this is actually going to use the serial port to display values to us. So this tells you what it does, but to test y'all, I'm going to cover that up. And can someone tell me what it's going to do just by looking at the code? Actually, do you want me to turn the lights down a little bit? Is it hard to see that? Do y'all want the lights lower, or are y'all good? Okay. Yeah, it's really nice. So they actually tell you, they put in these comments, so like it's kind of easy to know what each part does. So here they're going to read in an analog value. What pin are they reading? What pin's the voltage being read on?
Whichever one they assign.
Yeah, it's kind of a trick question. You can't tell. You have to go up and see, well, what is the analog input pin? If I go up, I see that they made it A0 is the analog input. And then they're mapping it to the range of analog out. So this is kind of like in the Circuit Python I gave y'all, one of them. Remember, like, you got in a number that was between 0 and 1023, and you kind of wanted to map that to a voltage. Like 1023 corresponds to 3.3 volts, and 0 corresponds to 0. So this is, it's actually going to read in an analog value on pin 0, and then write that value to an analog output. And the analog input can change between 0 and 1023, but the analog output can only change between 0 and 255. And I think, I might be wrong, but I think when it says it's going to make an analog output, that's kind of the same way that when you write analog write, that's the same thing we were using to dim the LED on. Well, we weren't dimming, but if you wanted to dim an LED, you could write an analog value instead of a digital one. That way you can like get intermediate values. But it doesn't, it's actually not dimming it. It's doing that PWM trick we talked about with the motors. You know, I was saying with a motor, one way to change the speed is by sending these pulses, and you change the width of the pulses. Well, it's the same thing with the LED. You can make the brightness of the LED appear to change very smoothly by doing pulse width modulation. So like, your eye can only see like at maybe 30 hertz or something like that. So if LED is flashing at like 1,000 times a second, your eyes are going to see kind of the average brightness value of it. So what you can do is you can flash it at like 1,000 times a second, kind of like you do with the motor, and just change how long it's on and off. And that lets you control the brightness of the LED. And your eye can't tell the difference. So I'm pretty sure when it's writing an analog out, it's not actually making analog voltage output. It's 0 corresponds to all the way off, and then intermediate values are more wider pulses all the way up to 255, which is all on all the time, which is just 3.3 volts. So, and then it's going to print out the sensor and the output value over the serial port. So if I upload this, let's see. And then if I look at the, I'm actually going to change the analog pin to pin 13 because that's the pin that the LED is on. So I think you should see the LED getting brighter and dimmer if it works the way I think it will. All right, and the pin that we're reading, see here's the sensor and the output. So the pin we're reading is, I think it was A0, wasn't it? So I'm going to stick this wire in A0, and if I ground it, see it goes almost down to 0. It's at 5, which is pretty close to 0, and the output got lower. And then if I connect it to 3.3 volts, it goes all the way up to 1023, which is the highest reading you can do. And see, the output is now the highest value, 255. And like I said, that's connected with pulse width modulation to this LED. So see, the LED is on pretty bright because the output value is 255. If I disconnect it, it got a little bit dimmer. And then if I connect it to ground, it'll go off all the way because now it's only outputting 0, or it's almost all the way down at 0. But I like this example because it's demonstrating how to read analog voltage input, how to output. It's calling it an analog output, like it's technically a PWM output, but it's kind of the same idea. And then it's also showing you how to write values out over the serial port. See, like here it's printing out sensor equals, and then it prints out the value of the sensor, and then output equals, and then the value of the output. Let me think.
Just reading like the floating voltage you were talking about earlier now?
Yeah, right now, because it's not connected to anything, it's just kind of floating. And like if I just, even if I touch it with my finger, it's probably going to change a little bit. It just kind of like depends on, it's kind of random when it's floating. Like, I don't know if y'all can see when I touch it, it gets a little bit dimmer, but it doesn't go all the way out. It's like, because it's kind of just floating around. I'm touching it, not touching it, touching it, not touching it. And it depends what I'm touching. Like, your body's like a big resistor, so it lets some current flow through. So like, if I put one finger on the USB port, which is grounded, and then I touch it, it goes down a little bit because I'm like, it's like you've got a big resistor going to ground. But if I then touch the 3.3 volt and then I touch it, it goes up because it's going all through my left arm, through my body, through the right arm. So it's like, it doesn't take much current to make it float up or down, which is a good thing because you don't want the voltage you're measuring to take a lot of current, because like that affects the thing you're measuring. Does anyone have any questions with this example, how it works? One interesting thing that's different than CircuitPython is you see up here they made the variables up here before they used them. Like they said sensor value and output value equals 0, and then they used them for the first time here and here. Do y'all know why they did that and why you didn't do that in CircuitPython? Also, does anyone know why they put INT at the beginning of it?
Doesn't that stand for integer?
Yeah, you're right. And why do you have to put that? Like with CircuitPython, you didn't have to put that.
CircuitPython just assumes it's an integer unless you tell it otherwise.
Yeah, I think that's kind of true. So with C, and C++, which is what Arduino is, before you ever use a variable, you have to it's called declaring it, which is kind of like in CircuitPython, you know how when we wanted to use a function, we had to put it at the beginning so it knew about that function. It's kind of the same thing. Before you use a variable, you have to declare it and tell C, hey, I want to make this variable, I'm going to call it sensor value. And you don't have to even put the equals 0. You can just declare it. What that does is it sets it to 0 to start with. If you don't set it to 0, it could be any random thing. So it's normally a good idea to set it to 0 at the beginning, like they had it. But you have to tell it what kind of variable. And there's several different ones. Like if you you could just Google it, C data types. So there's the one we just saw was int, which is an integer. And see, there's all different kinds. There's a character, a signed character, unsigned character, short int, long int. There's a bunch of different kinds. The only ones that you'll probably ever really use are going to be an int for integers. And if you have a number that has a decimal place, you're going to use a float, which stands for a floating point number. And the floating point numbers can hold a decimal number, but the ints, they can't. It's just going to round it to the nearest number.
I think I've also seen bool used regularly for just
Yeah. So there's you can actually make your own data types in C, which is kind of cool. So you could make bool isn't built in, but I think Arduino supports it. See here it talks about it. You can read all this, but let's see a little bit simpler chart. So, but the important thing is in C, different data types take up a different storage size. So an integer, I believe it's actually 4 bytes that it takes up. And it takes up 4 bytes in memory. Even if it's set to 0, it still takes up 4 bytes. It's like when you tell C, hey, make a variable, and it's going to be integer, it says, okay, let me find 4 empty bytes in my memory, and then the variable is going to go in there. So another thing you'll see sometimes is a character, char, and it's just 1 byte. So it's a number, but it's only 1 byte. And because it's 1 byte, with 1 byte, you can only represent a number between 0 and 255. Because you can just figure that out with a byte is 8 bits. And so with 8 bits, you can only count to 255. With 4 bytes or 32 bits, you can count all the way up to this number, which is 2 million. Basically, it's 2 to the 32nd power. So it's it can hold a bigger number, but it takes up more space in memory. So it's kind of a trade-off. But basically, you might see char being used or character being used, and you might see int being used, and you might see float being used sometimes. But float, if you remember, I said float is also 4 bytes, just like int is, but it can be a decimal number. So if I wanted to measure a voltage and it was 3.5 volts, that would need to be a float. But the problem is floats are actually a lot slower than integers because there's a lot of extra, it's harder to do decimal arithmetic than just integers. So a lot of times people will do tricks to avoid using them unless absolutely necessary because they are a lot slower, especially with a microcontroller. Like on your desktop, it's fast enough that it can do floats all day long. But anyway, so you have to just tell it what kind of variable, and usually it's going to be int is the most common one. like technically, so you know how the analog output can only go between 0 and 255. That means that technically this could be a character, because if you remember, character can go between 0 and 255. But the only advantage to that is it uses less space in memory, but we're only talking about saving 3 bytes, which isn't very much, because you've got, I think, megabytes of memory on here. But if you had like a bunch of numbers, it might matter actually, like if you're saving a bunch of numbers. Let's real quick, before we move on, let me hook up my oscilloscope to that pin just to see. So one thing I don't know about the analog write is, you know how it's pulse width modulation I said that dims the LED? I don't know what frequency it runs out because I didn't tell it. So like, you know how the pulses repeat at some frequency? It's obviously faster than 30 hertz probably because I can't see it blinking. So if I look with my oscilloscope though, I should be able to tell what it is exactly. So trigger. All right, there's the pulses. Let's see how far apart they are. There's one, and there's one. So the time between them is 1.36 milliseconds. Which my handy dandy calculator on my watch, let's see. That's 735 hertz. So it's not quite 1,000 times a second, a little bit less than that. And see how the width of these is jiggling around? It's because this is just floating. If I ground it, see they go almost to 0, the widths do. And then if I, and you can, what we can do is open up the serial monitor. If I make this small enough. So you can see the output right there. And then if I move this, so I just disconnected it and it's floating now. And if I move it to 3.3 volts, the output's 255, and you can see it's almost completely, it's almost on all the time. It's just like a little bit that it drops out. Let me zoom in a little bit on that. So apparently it can't go completely on all the time. Like it still has to go low for a little bit, but it's very small. You can barely see it. So could I just hook up a motor to this pin and change the speed of the motor using this?
Or buy a new board.
Yeah, exactly. So the problem is, well, why would that be?
Because the current that the motor draw will burn out the board.
Yeah, exactly. So even though like you can make an LED dim and change its brightness, the pins on most microcontrollers, like this is coming out of pin 13, they can only put out like maybe 10 milliamps, not much current at all. So if I hook up a motor that takes like an amp, it's gonna be too much current for that pin. So even though it's fine for dimming LEDs on and off, don't try to drive a motor like that. The motor driver board does the exact same thing. It does PWM, but it can output like over an amp, so it's enough to drive the motors. Also, another disadvantage of this is I can only drive the motor one direction. Like because, remember I drew the H bridge before? That's how there's an H bridge in your motor driver board that lets you change direction. Since I don't have an H bridge on this, I could just, when I hooked up the motor, even if the motor was small enough that I could drive it with this pin, it would only go one direction, and I couldn't switch the direction of it. So, and it's interesting, there's probably a way to actually change the frequency of the PWM from the 700 hertz. There's probably some built-in function. I just don't know what it is off the top of my head. Let's open up another example. So this is very similar. Except it reads the brightness data instead of being from this pin, this analog input. It reads it from the serial port that you type in, and then it writes the brightness to that LED. So you have to send it a number between 0 and 255, and it'll just write the brightness to that. There's a little bit of a tricky thing when it comes to serial communication. If I upload this and I just try to write, like, say I try to write 255 to it and I hit send, it's not actually going to work because with the serial port, when I type in a letter or a number, for example, 255, and I hit enter, what it's actually doing is the data sent over the serial port is just numbers. So if I type in like A, B, C, it has to send those letters somehow as numbers over the serial port, because that's all computers understand is numbers. And there's actually a chart you can look up and see what number the A, B, and C get turned into. And with this serial port in the Arduino, it uses something called ASCII. It's just a way, it's like a table you can look up, and in this table it'll tell you an A is this number, a B is this number. And also the nice thing about ASCII is each letter is 1 byte of serial data. And serial data is actually broken up into bytes naturally. So like when you send a bunch of serial data over to the board, it breaks it up into bytes. So you have to, like, each byte is 8 bits. So it's like sending, you can't send half a byte or something. It's only sending full bytes over. And this is going to take up 3 bytes because it's 3 letters. And I can tell you what 3 bytes if I look at the, if I type in the ASCII table. There's something called ASCIItable.com. So if you see here, here's a capital A right there under the cursor. And the decimal, the number that corresponds to is 65. So it's going to send the number 65 for an A. Capital B is going to be 66. And capital C is 67. And the funny thing is, like, what that means is even if I type in the number 1 and I hit send, it's not going to send the binary data of 1 over the serial port. It's actually going to come to this chart and see, here's a 1 right here. It corresponds to the number 49. So it's actually sending the number 49 over. So like, because of the way this code is written, it just takes the raw serial data and puts it in the brightness. if I put in a 0, it's going to write the brightness to 48. And if I put in a lowercase u, it's going to write the brightness to 117. So it's kind of confusing. And this is, I've always found this really annoying with serial communications and Arduino. It's not just Arduino, it's also like this with CircuitPython and everything. It's just that there's a difference between sending like raw binary data and sending, I guess what I'm trying to say is there's a big difference between sending 255 by typing in 255 than actually sending the raw binary data of 255. Like you can write a Python program that instead of, because when I hit enter here, it's going to look up 2, it'll send that byte, it'll look up 5, it'll send that, and it'll look up the other 5 and send that. But you can also write like a Python program that actually sends the raw data 255 out. It's kind of like a trade-off between complexity on your laptop versus complexity on this thing. So it's easier for this thing just to read the raw binary data like this, but then it means you have to write like a Python program, which is kind of a headache. You can also put code on this that will be able to understand the more complicated ASCII numbers, which means you can just type them in on the console. The downside is it's more complex code for this, but it's not too bad. So if I go to communication, and I think it's called serial call response ASCII. Nope, not that. Not bad. Yeah, so this function, it actually, instead of just raw reading in the raw serial data, there's a built-in function called serial.parseInt, and it'll actually convert the ASCII numbers, the ASCII representation into a binary number. So that basically what it means is this program expects, what it does is it writes the brightness of a red, green, and a blue LED. So you can actually buy RGB LEDs, it's a red, a green, and a blue LED all in one package, and they just have, they have 4 pins because they've got the ground, the red pin, the blue pin, and the green pin. And they're kind of cool because you can pretty much make any color with those 3. So what this expects is to have pin 3 go to red, pin 5 go to green, and pin 6 go to blue. And then you send it the RGB value. So it's like if I want red on all the way to 255, if I want blue, or if I want, it's red, green. So if I want green all the way at 0, I type in a 0. And if I want blue somewhere in the middle, I could do like 100 for blue. And if I hit enter, this is going to send several bytes, more than just 3. It's going to send a byte for the 2, a byte for the 5, a byte for the 5. There's a byte for a comma, like there's a comma in the ASCII code. So it's going to send out a lot more data than I think. And then on the other end, this is actually going to turn it back into the number 255 for red, 0 for green, and 100 for blue. So let me change the red pin to pin 13, because that's the pin that the LED is on. And also, for some reason, they invert the colors. So that 0 is full brightness, which is kind of confusing. So I'm going to change that real quick. See, they're doing 255 minus the value. And then they write it out. So if I upload this, and then I open up the serial port, and let me also open up my, actually no, I'm not going to do that. I was going to say the oscilloscope, but I'm going to hold off. If I hit enter, the red light just came on my board. So you can see the red light came on. if I instead change this number, the first number to 0, that should make this light go off. Because if you remember, I'm not even using the green and the blue numbers. It's writing them out to pins, but there's nothing connected to those pins. And I told it that the red should go to pin 13, which is what this LED is connected to. But if I write a 0 there and I hit send, you can see it went off because it wrote a value of 0 to there. If I go back up and I put it to some intermediate value like 50, it's on, but it's on a lot dimmer. And then if I go all the way back up, I can write it to 255. And you can see it's on a lot brighter. So it's really nice to be able to communicate like that over serial. Because like a lot of times you might have a more complicated program running on your computer and it's sending data to the Arduino. So here I've got the oscilloscope again connected to pin 13. So if I write it, say I write it to 100, see it's on, not all the way on, not all the way off. It's kind of intermediate. Does that make sense about the difference between the ASCII and the raw data, kind of? Yeah, it's confusing. I know a lot of times I've been confused. Like you'll get you might buy something like a temperature controller, and it's like just send it the temperature over serial, and it'll go to that temperature. And you're like, well, does that mean I send the ASCII numbers of the temperature? Like for 100 degrees C, do I type 1 byte for 100 and then 2 bytes for the zeros? Or does it mean I actually send it the byte 100, which would actually, if I look it up in this table, 100 would look like the lowercase d in ASCII. So it's kind of weird. And if a good way to open it, to figure that out, if it's talking, because some devices talk in binary data and some talk in ASCII, is if you open it up and you like turn on the serial port, if it is, actually I can probably show you all that real quick. If it's sending out raw data, it'll just look like kind of like gibberish on the, like it'll be all these random numbers from the ASCII table showing up as the number changes. So it'll look really weird. Like, let's see. Oh yeah, I forgot about this. So this is the example we already looked at, which it reads in the value, prints it out to serial, and then it writes it out PWM. This is working, as you can see. It's not gibberish, and it's because if you do serial.print and then a number, it converts it to ASCII. And I think if you do serial.write instead of serial.print, which sound like the same thing, it'll write out the raw value of that number. I think that's how it works. I believe. Yeah, so that's the difference. So if you do serial, see before it was serial print and then the sensor value, you actually don't know how many bytes that's going to send, because if the sensor value is 1,000, it's going to send a 1 and then 3 zeros. That's going to be 4 bytes of data that gets sent out over serial. But if I change this to write serial dot, it's only going to send 1 byte, and the byte is going to be equal to this sensor value, which means that the sensor value has to be between 0 and 255, because that's 255 is the highest you can count with 1 byte. So let me change this to write, and it should look weird. Okay, yeah, like I don't know. See, it's like a backwards question mark.
But also, you changed the one that could be way higher than 255.
That's true. Yeah, so I don't know what it does if it's higher. That might be the question mark. But see, look, see, it's getting like these random characters popping up. It's because that number is changing, and it's printing out the ASCII. Oh, look at that, integral signs. That's really weird. I don't know why it's doing integral signs. I think, is that in the ASCII table? It might be that if it's outside of a certain range, it. Actually, I don't know. I'd have to look more into it, because I don't think integral. Anyway, but y'all get the idea, kind of like, if you see weird gibberish stuff coming over the serial monitor, it probably means that the data is being sent in its raw form. I'm not sure. I don't see the integral sign in the table, but I don't know. Anyway, it's kind of fun. And then if you want to get really fun, what you can do is just have it constantly write out just the sensor value over and over and over again. Also something kind of cool. So you know how when you do print line, it makes a new line. That's just a certain ASCII character that tells it to go to a new line. So like, if it gets, I think, see right here it says, I think it's called a carriage return. Yeah, so if it sees the number 13, it's a carriage return, which makes it go to the next line. Do y'all know why it's called a carriage return? Yeah, so like ASCII is so old, it literally goes back to when typewriters were being used, and like the carriage was the thing, I guess, that moved on the typewriter. So this stuff is like from the 60s. It's that old. So there's a lot of weird, like historical things that are kind of useless now. Like you won't use most of these. So let me change it. So now it's just going to write out the sensor value over and over and over again. So if you see it jump to a new line, it's because it saw the number 13, which it said, oh, that's a carriage return. You go to the next line. See, it's just kind of scrolling randomly. Here, let me put in a wire. I don't even know where it went now. I lost it. Anyway, if you see weird stuff, it's because it's binary data. I think I froze something. Oh no. I killed Arduino by...
Probably trying to keep all that in its memory.
Yeah, it's probably like streaming out a crazy amount of data. So don't do that. Be nice to your Arduino. Don't kill it.
We didn't even have too many backwards question marks.
Yeah. Death by backwards question marks for the Arduino. Wow, it's really dead. Weird. Oh no, I need will because I forget how you force something to die on Linux. Anyway, it's actually time to go anyway, so that works out perfect. This died on purpose, actually. No, but so I just kind of want to go over some more like programming topics kind of with Arduino to get you a little bit more familiar with it, since it is new. But so this week I'd like for y'all to get it working on your computer, try out some of the examples. It's nice because you can literally just click on the example and click upload to board and just watch it run. So I want y'all to go through that. And I also want y'all to try to decide what, you don't have to narrow it down to one idea, but come up with a couple ideas for what you would like to do for your final project. And then send those to me, and I'll send out the email instructions where to post the ideas for the project. But pretty much, just want to get kind of a head start on that, so we can order stuff and also pick out good projects for y'all. So, anyone have any more questions? All right. Well, thanks, guys.